I'm here to talk about EuroReakt, which is my library of currently 90 blocks that I've made for Reactor 6. I've spent the better part of the last 2 months working on this library. So what I do is I'm currently working on my PhD at UC Santa Barbara in the Media Arts and Technology Department. Yeah. Sorry, that was a loud laugh into the mic. So what I do is I currently teach a class on modular synthesis with Curtis Rhodes. We are working on teaching students how to use these really complex tools, but we're trying to simplify these complicated ideas into a musical language. A lot of modules that you buy, a lot of modules that previously existed, a lot of the internet resources are kind of written with an engineering bent. Which has always been kind of amusing to me. Like you open a manual and it's like, this is out T connected to out D, and you have to tell your students, oh, that's a toggle. So the first thing I want to show you is a sort of old school breakbeat generator. This was something fun that I threw together last night in about 20 minutes. Let me just hit play on this and then I'll explain it. So this is all done inside of Reactor. There's not some external sequencer that's plugged into Reactor. We're not communicating with MIDI or some external communication protocol. This is all in the box. I can look at the patch, and it seems pretty complicated when you first look at it. You have a burst generator, a gate delay, a sequencer, all sorts of things. So when you pick this apart, it's fun to kind of explain to people how to think of modules. A lot of you have been in bands before. You've played with other musicians. You have to learn how to speak music to other people. You have to learn how to communicate your ideas. You can't just say, play something for me. You have to kind of give them genres. You have to give them beat ideas. You have to give them like scales, changes that you want to hear. So modules, if you think of them like musicians that you're talking to, it ends up being a lot easier to compose. You're sort of giving the modules rules, and the modules will give you music in return. So one of the things on here is a burst generator. A burst generator takes in a message, just an impulse, and it will return a number of repeats afterwards. So here I have my burst generator. It says I'm going to have 11 repeats. So every time it receives an impulse, it gives me 11 repeats afterwards. So when I gate this, sorry. What's happening is it will generate 11 bursts, and then it will stop. We have a gate delay at the end. So when the burst generator finishes, it sends a message to the gate delay. The gate delay takes a message, waits a moment, and then spits it back out. So we have this feedback loop here between the burst generator and the gate delay. We have this burst, pause, burst, pause. So it's this nice start, stop, break technique that you hear a lot in 90s breakbeat recordings. So by giving it these two simple rules, I'm able to make a lot of complications. I don't have to sit in my MIDI sequencer and drag these notes around and make them precise and make them exactly what I want. I can give it a general rule set, and then I can manipulate it so that it gives me endless variety. So I have a few presets here where I change just a few of the knobs, and we'll get completely different rhythms. So this will be the same drum sounds. The drums are also part of EuroReakt. And then I'll just hit play again. Okay, that one didn't want to stop. I was having too much fun. So I should mention that EuroReakt is available for free on the user library. So if you have Reactor 6, you get to use all of these blocks. So there's 90 and counting. What's fun is, so this originally started as kind of emulations of existing modular hardware that I wanted to see in software form. But it's kind of changed over time to be, okay, I haven't seen this done in software, or I haven't seen it done in an easy way. So here's a funny block I made last night. So what this does is this will load any sound that you want into this sampler. You then plug in an LFO or any audio signal you want, and it will scroll through the sample manually. So you can control the playback of the sample using any external modulator. So if I slow down my LFO, we can hear sort of the original file. So we're going from 0 to 1. We're using a ramp wave here. If I change this to a sawtooth, we're going backwards through the file. We're starting at the top, and we're moving downwards. So if I manipulate this, I can change this to, say, for instance, a triangle wave. Now we're going twice as fast upwards, twice as fast downwards. I can control the speed of the LFO. I can control the shape of the LFO so it bounces a little bit at the bottom. So this gives us sort of a weird manual scrub technique. This is something that you don't really see a lot in software because you have a modulator, you have a scrubber. You have to have them connected in a way that makes sense to the user. So you typically have, for instance, in Contact, you would have to draw the envelope over the waveform, and the envelope would move back and forth, and you can see it move through the waveform. This, you can input anything you want. It can be an LFO, it can be another audio file, whatever. It will just go through the sample and play new stuff for you. Okay. So let me switch over to a template I made. Okay, so I'm going to connect reactor to an external eurorack synthesizer. Oh, there I am. Hello. Okay, so I have this little lunchbox case here. Inside this lunchbox, I have an oscillator. It's Braids by Mutable Instruments. It's a really excellent oscillator. I also wanted to give Braids a shout out. Olivier at Mutable Instruments has allowed me to take his designs, which are open source, and put them into EuroReakt. So we're taking literal hardware designs from the code and porting it over to software. Also, Stephen from Noise Engineering is in the audience tonight. He's let me take his newest oscillator, Loquelic Iteratus, port it over to EuroRack, so thank you to both of them. It's really cool. Okay, so inside my case, I have the Mutable Instruments oscillator. I have two modules by Expert Sleepers. These take optical cables from my audio interface and plug them directly into the modular. So the reason I'm using optical cables is modulars span the entire time scale that we use. So they can take 30 minutes to generate an LFO waveform. They can go up to, thousands and thousands of hertz. They can generate sounds that are outside of the range of human hearing. Most audio interfaces have DC blockers on them, which means that they filter out the sounds that are below the range of human hearing. Unfortunately, these are the modulation signals in a modular synthesizer. So by using an optical cable, by using a digital cable, I can take modulations and bring them into the computer. So we'll start off by taking the output of Braids, plugging it into the input of my interface. Now, Reactor's a little bit little down here, but you can see the scope on my computer. You can see that it's definitely receiving sound from Braids. Now with Braids, I can just change all sorts of models on here and get new sounds. So if I want to hear this, what I can do is I can go to the library. I'm going to grab a mixing module so that I don't blow out the speakers. I'm I'm going to plug braids into the mixing module. I can see the level that it's currently at, and I can plug this directly into the output. So here's braids. I'm manipulating the hardware, and I'm looking at it inside of Reactor. So nothing too unusual. This is just an audio interface. Nothing crazy here. Now what I can do next is I can take an output from maths. Maths is like one of the classic EuroReakt modules. It's a dual envelope generator. It can generate envelopes anywhere from 30 minutes long to a couple thousand hertz. So it goes with what I'm saying. Modules don't really have this whole separation between sound and composition, which I'll get more into in a moment. So if I take the second input and plug it into the scope, we set the scope to free running. Oops. Panel. I can change the speed on maths to make it faster or slower. I can see this sort of slow modulation signal here. So let's say you just bought a modular. The mistake I always see people make when they buy a new system is they tend to buy all the cool modules up front. They buy the sound generators, they buy the filters, they buy the sequencers, and then they don't buy the useful utility modules that turn it into an instrument. So one thing that people need much more of in their systems are VCAs, voltage-controlled amplifiers. So a voltage-controlled amplifier, as you saw in the Monarch demonstration, takes a signal and modifies its amplitude based off of an external modulation. So what I can do is I can take this envelope from maths and control the volume from braids. So here I'm going to plug braids into the VCA, plug the VCA to our output, plug maths into the modulation input of the VCA. And then let's just turn up this modulation signal. So it may not seem that crazy, but what is happening is actually pretty cool. We're taking an external analog modulation source, we're taking an external digital oscillator, we're plugging them into the same computer, and then we're making them interact inside the computer. We're not using external modules for this. So I can change the controls on maths, and it will change the speed of the modulation inside of Reactor. So now Reactor is kind of a glue for your system. You can have a bunch of modules and you think, oh man, I need this one, but it costs $200. So you can just drop one in Reactor and use it in a pinch when you need it. So one other thing that I really like is Reactor does MIDI to CV. So what I can do is one of my EuroReakt blocks is called, it's called meta control. So what meta control does is it generates offsets. An offset is just a stationary modulation signal. You control where it sits manually via a knob. So what I can do is I can take this offset generator and I can plug it to the output of my computer. So you can see on my system when I move this block, okay, look here at this red light. Okay, so it's receiving control voltage from the computer. The computer's sending a digital message across this cable, and it's now being converted to a voltage. So what I'm going to do is I'm going to plug this output from the computer into the maths speed control. So let's listen to maths. Now let's change the speed control on the computer. So what I'm doing now is I'm taking two modules, putting them inside the computer, having the computer generate another modulation source to communicate outside the computer. And what makes this really nice is I can right-click on this knob, say MIDI and OSC learn, turn a knob on my controller, and now if I just turn up my modular, I can just sit here on my MIDI controller, and and not deal with this mess of cables in front of me on stage. So another great thing that Reactor can do now is you can take your MIDI controller, you can have your patch on stage, and you can deal with a cleaner system than cables and knobs. So again, I think this is a really great tool for modular users. Okay. So about 5 minutes left. So one of the things I was asked to do, if I had time, was to show you how core works in Reactor. So on the user library is a blocks template. It comes with a number of pre-width blocks. These are just standardized widths that look great. There are also a collection of knobs to use. So if I use this light on dark, I can see sort of the collection of standard Reactor knobs. So if I open up this new block that I dropped on here, dark width equals 4, I can see it has a bunch of inputs that you would commonly use: pitch, FM, gate, reset. These are all generated for us. I'm just going to do a 2-in, 1-out block. So we have the process and we have the panel. The process is our DSP. The panel are knobs and controllers. So I can take one of these knobs from the template, I can open up the template and I can say, I want a modulatable large knob. I can paste 2 instances of this inside our new panel. So here's our new panel. Connect them to our processor, hook them up to our modulation AB, and then if I want to move them around, I unlock our panel, I select the knob, and then I use the arrows to move the knobs around. So I want these to be simple volume knobs for whatever the input is. So I'm going to lock the panel, I'm going to open up our processor, and I'm going to say, okay, here's input left, here's input right. And I'm going to delete everything except for these 2 inputs and the output. So these 2 knobs are currently coming in on C0 and C1. These are our modulation inputs. So if I want to change the volume of a signal, all I need to do is multiply the signal by our modulation signal. So I go to math, I go to multiply, I say take input left, multiply it by our modulation signal, output it. So if I take a block like an oscillator, I can go to EuroReakt, I can open up the oscillator library. You have about 20 to choose from, maybe more like 15. I'm going to pick the summation synthesis oscillator that was designed by Noise Engineering, and I'm going to plug it into the input, plug that into the and plug that to our audio output. So now I can turn up this knob. You can hear a very low frequency wave, probably not good to play on the speakers. So we'll raise our frequency a bit. So yes, we made a volume knob. All right, so that's my presentation. So we're going to do 5-minute Q&A? Okay, right. Do you have questions for me or about Reactor, about building, about EuroReakt? Yes. Okay.
Yeah. Oh. Hey, where are you? Who asked the question? How you doing, sir?
Good, how are you?
Pretty good. I was wondering, I know Reactor is you're using modules. Are you able to create tracks and patterns and tie it into the program? Just say, for instance, that if I sample a drum pattern, then I set it at 80 BPM. Am I able to tie that into the module also?
So yes and no. There are a few ways of going about it. Reactor can be used as a plugin. So you can take the entirety of Reactor and use it as a VST, audio unit, AAX, sort of any plugin that you want. So if you're in, for instance, Ableton Live and you have a drum loop, what you can do is you can have your drum loop playing in Ableton at 80 BPM, and you can have Reactor existing as a plugin. And so you can have your drum loop however you want it. You can have Reactor receiving MIDI input. You can have it receiving other inputs. You can have it acting as a processor for the drum loop. So there's a number of ways of going about it. There are also samplers that have been built for Reactor, so you can load the drum loop inside as a module and play it in there.
Oh, okay. Yeah, because I've seen how you did it. Because I actually use FL Studios, and a lot of the modules that you have, those are GST and preset. And I was wondering if you can tie record and FL Studios into each other.
Yeah. So with Reactor, you can, for instance, have 8 inputs if you want. And in your host, like FL Studio, you can route to any of these inputs. You can have, for instance, track 4 go into inputs 3 and 4. So you can simultaneously use Reactor as a processor of all of the plugins in FL Studio. You can have it generate simultaneously. It's great. You can just have a lot of inter-app communication.